ever try to predict the stock market? I mean, it's like trying to herd cats,
Yeah.
right? Total chaos.
Oh, yeah.
But some researchers are trying to do just that, using some really wild techniques.
Hmm.
Today, we're diving into a paper called Online Learning Techniques for Prediction of Temporal Tabular Datasets with Regime Changes.
Okay.
And this deep dive, we're not trying to turn anyone into a day trader,
Right.
but we are going to learn how these researchers are building these smarter, more robust models, prediction models in finance. And we're going to find some interesting stuff out, like why simpler models might be better than using these complex neural networks.
Interesting.
So are you ready to dive into the world of market predictions?
Absolutely. Let's do it.
Okay, great. So the paper starts by explaining just how difficult it is to make financial predictions.
Yep.
And it uses some pretty dense terminology to do it, like stochastic, non-stationary, and non-ergodic. Can you break those down for us a bit?
Sure. Stochastic basically means random. Non-stationary means that the underlying patterns are always changing. And non-ergodic means that just because something happened in the past doesn't mean it's going to happen in the future.
Okay, so basically predicting the financial markets is like trying to predict the weather.
Pretty much, yeah.
Okay. So in this kind of unpredictable environment, how do these really sophisticated deep learning models, the ones everyone thinks are like these super prediction machines,
Yeah.
how do those actually fare?
Well, you would think that they would do really well, but they actually often struggle with this kind of data. They tend to get overfitted, which means they basically memorize past market behavior instead of understanding the underlying patterns.
So they're kind of like that student who just crams for the test and then forgets everything the next day?
Yeah, exactly. And then when the market does something unexpected, like a financial crisis or a global pandemic, these overfitted models, they don't know what to do.
Okay. So if these fancy neural networks aren't the answer, what is?
Well, this research is suggesting that simpler models like gradient boosting decision trees or GBDTs,
GBDTs.
yeah, these might actually be more effective.
I'm all for simple solutions that work. So tell me more about these GBDTs.
Okay. So GBDTs work by combining a bunch of different decision trees,
Okay.
each of which is trained on a slightly different part of the data. You can kind of think of it as a panel of experts, each with their own area of expertise.
That's interesting. So it's not like one super brain, but like a team of specialists.
Exactly.
Okay. So what makes this team approach better for something like the stock market, which is so unpredictable?
So first of all, GBDTs are more robust, meaning they're less likely to be thrown off by these sudden market shifts.
Okay.
And then second, they're much easier to interpret. So you can actually see how they're arriving at their predictions.
Oh, okay. And that's super important, especially when you're dealing with people's money.
Oh, yeah, absolutely. Transparency is key.
Right. So how did the researchers actually test how well these different models handle these market upheavals, or, as they call them in the paper, regime changes?
Okay, so they used data from this really interesting competition called the Numeri Tournament.
A tournament?
It's this real-world testing ground where data scientists compete to build the most accurate financial prediction models.
Oh, wow. A data science tournament? That sounds intense.
It is, but here's the really cool part. The participants, they get anonymized data, meaning that they don't know which specific stocks they're looking at. The focus is on predicting the relative performance of stocks, not picking individual winners.
So it's about understanding the whole market, not about trying to outsmart the market by making individual trades.
Exactly, yeah. And the researchers, they were actually able to use the Numeri data to define periods of high and low volatility in the market, to map out the periods where things were really going crazy.
So they created a roller coaster of market conditions.
Exactly.
Okay. And what did they find? Like, how did the models do?
Okay, so the key thing that they found was that consistent performance across different regimes was the key to a successful model. If a model only performs well during calm periods and then crashes and burns when things get a little turbulent,
Right.
it's not going to be very useful.
Of course, you need a model that can weather the storm.
Right.
But how do you actually build a model that can handle those wild market swings? Because it's not like you can predict exactly when those are going to happen.
Right. So that's where things get really interesting. The researchers introduced this technique called dynamic feature projection. Imagine that you're sailing a boat and the wind changes direction suddenly.
Okay.
You wouldn't keep your sales in the same position, would you?
No, no, of course not.
You'd adjust them.
You'd adjust to the new conditions.
Exactly. And that's basically what dynamic feature projection is.
So you're saying the model needs to be able to adjust its sales as the market winds shift.
Yep. Exactly. Dynamic feature projection is all about teaching the model to pay attention to the right signals at the right time and to kind of reduce its reliance on specific factors that might become less predictive when the market takes a turn.
Okay. But how does the model know which signals to ignore? It's not like it has a crystal ball.
Right. So the researchers looked at different strategies for choosing which features to basically project out. And they found that a surprisingly simple approach called low-mean projection worked really well.
Low mean. What's that?
So think of it like decluttering. If a signal hasn't been very useful in predicting recent market movements, chances are it's not getting much use when the market takes a sudden turn.
So the model throws out those less useful signals and focuses on the ones that are still giving it valuable insights.
Exactly. It streamlines the model.
Okay, that makes sense. But what if you have multiple models, each with their own strengths and weaknesses? How
Right.
do you choose the best one?
So that's where this concept of dynamic model selection comes in. Instead of picking one model and sticking with it, you
Okay.
create what's called a model ensemble.
An ensemble?
As like a team of advisors, each with their own perspective on the market.
So like a financial brain trust.
Yeah, exactly.
But how does the model decide which advisor to listen to?
So it basically uses a rule based on recent performance. The model that has been making the most accurate predictions lately
Right?
gets more weight. And the researchers found that a simple strategy called momentum was actually really effective.
Momentum. So picking the model that's on a roll.
Yeah, pretty much. But of course, past performance doesn't guarantee future results. It's just one piece of the puzzle.
Right. So we've got these GBDTs, this tournament, and these techniques for making models more adaptable. Where do we go from here? What's the bigger picture?
I think what's exciting is that this research has implications way beyond financial markets. These techniques for building robust, adaptive models, they can be applied to any field where you're dealing with complex, evolving data.
Okay, now that's interesting. Tell me more.
So think about climate modeling
Yeah.
or disease forecasting. We're talking incredibly complex systems here,
Yeah.
where predictions are notoriously difficult. These online learning techniques could be a total game changer.
So we could potentially use these same techniques to understand and predict things like climate change and disease outbreaks.
Exactly.
That's
yes.
incredible.
And that's what we're going to be diving into next.
Okay, stay tuned because we're about to explore the wider implications of this research and how it could change how we understand the world around us.
So before we were talking about these GBDTs
Yeah.
and how they might be useful for more than just picking stocks.
It's pretty amazing to think that we could use the same techniques to navigate the stock market and also tackle some of the biggest challenges we're facing, like climate change and disease forecasting.
Right.
Can you unpack those a bit more for us?
Sure. So let's start with climate modeling. It's a really complex system with so many variables, and we don't fully understand how they all interact. It's like trying to predict the path of a hurricane,
Right.
but on a global scale.
Right. And just like the stock market, there are these regime changes in the climate, right?
Exactly, yeah. So
Yeah.
think about things like El Nino and La Nina, these large-scale climate patterns.
Right.
They can cause like droughts in some areas, floods in others. Traditional climate models, they often have a really hard time predicting these events.
Okay. So how could these online learning techniques that we've been talking about, how could they help us build better climate models?
So imagine a climate model that can adapt as new data comes in,
Yeah.
from satellites, weather stations, ocean buoys.
Okay.
It wouldn't be stuck in the past, relying on outdated information.
So it would be a model that's more like a living, breathing thing
Yeah.
than a static textbook.
Exactly. And this ability to adapt would be super important for making good decisions about climate change mitigation and adaptation.
It really is fascinating to think about all the possibilities. But let's shift gears a little bit
Okay.
and talk about disease forecasting.
Yeah.
How could we use these techniques in that field?
Okay, so think about how difficult it is to predict how a disease is going to spread.
Yeah.
You've got population density, travel patterns, vaccination rates,
Right.
even climate change impacts these things.
Yeah.
And then you've got new diseases emerging all the time, and existing ones are evolving.
Right.
So you need a model that can keep up with all of that change.
Right. You need a model that can keep up.
Yeah. Imagine a disease forecasting model
Mm.
that could not only track how known diseases spread,
Right.
but also identify new potential outbreaks. This kind of early warning system could be really valuable. It could give public health officials time to prepare.
As we're talking about all these applications,
Yeah.
it seems like there's a common thread here. It's not just about making smarter models.
Yeah.
It's about using models that are fundamentally different in how they approach the problem.
What do you mean?
So traditionally, we've thought about prediction as linear.
Hmm.
You look at the past, you find patterns,
Right.
and then you extrapolate into the future.
Yeah.
But these online learning models are flipping that idea.
Yeah, you're right. It's a completely different way of thinking about it.
Yeah.
It's more about embracing uncertainty, about building models that can adapt.
So less about predicting the future, more about navigating the present.
Exactly, yeah. They're less about finding the one right answer
Right.
and more about finding a solution that can evolve
Hmm.
as the problem does.
This is all really interesting. But let's be realistic.
Yeah.
What are some of the drawbacks to these online learning approaches?
Sure. So one of the big ones is that these models, they need a ton of data to learn.
Right.
If the data is bad, the model's not going to be reliable.
Garbage in, garbage out.
Exactly. And then there's interpretability. Even though GPTs are easier to understand than neural networks, it can still be difficult to know exactly how these models are making their predictions, especially as they get more complex.
So we might have a model that's really good at making predictions, but we might not always understand why it's making those predictions.
Yeah, that's a good point, especially in fields where transparency is really important,
Yeah.
like in finance or healthcare.
Exactly.
It's a trade-off,
Mhm.
accuracy versus interpretability.
And then there's the issue of unintended consequences. I mean, anytime you have a model that's constantly learning and changing,
Yeah,
there's always the risk that it could start doing things that you don't expect.
that's true. We need to be really careful about how we design these models and make sure that we have some safeguards in place.
So it's not just about making smarter models. It's about making models that are aligned with our values and that we can use responsibly.
Absolutely. It's about making sure that these models serve us and not the other way around.
This whole conversation has been really interesting. It's made me think about what it really means to predict something. Do you think these online learning models kind of challenge our basic understanding of prediction?
I think so. It's like we're kind of blurring the lines between prediction and reaction.
So less about seeing the future
Yeah.
and more about responding to the present.
Exactly. And it just reflects how complex the world really is.
Yeah.
It's not static. Our models need to reflect that.
It's like we're moving away from using maps
Hmm.
and we're starting to use GPS systems
Yeah.
that can adjust in real time
Chaka.
as conditions change.
That's a perfect analogy.
So we've talked about a lot of big challenges today, like climate change and disease forecasting.
Right.
But how can our listeners use these ideas in their own lives?
That's a great question. So the big takeaway is that in a world that's constantly changing,
Yeah.
we need to be adaptable,
Right.
willing to adjust course as we go.
So less like a train on a track and
Yeah.
more like a sailboat.
Exactly. And I think this applies to everything in life, personal goals, career decisions.
So it's about the journey,
Yeah.
not just the destination.
Exactly. And we can all do that.
So to wrap things up, what are your final thoughts on the future of prediction? How can our listeners, how can we kind of harness this power of online learning?
Well, I think the key is to be open to new information, to be willing to change our minds, and to remember that the future is not set in stone.
It's not something that's just happening to us. We
No.
can shape it.
Exactly.
Well, that's a great point to end on. This has been an incredible conversation.
Yeah, thanks for having me.
And to our listeners, we hope you've enjoyed this deep dive and that you've learned something new. And we'll see you next time.
Welcome back to the Deep Dive. We've been exploring how researchers are using online learning techniques to build these really cool prediction models.
Yeah. Ones that are more robust, more adaptable. And we've talked about how they can be used in everything from finance to climate change to disease forecasting. You know what's really interesting to me? It's how all this research is changing how we think about prediction in general.
Right.
It's like we're moving away from this idea that we have to know the future with total certainty,
Hmm.
and we're starting to use a more dynamic, more iterative approach.
Yeah. It's almost like we're trading in our crystal balls for a good set of tools.
That's a great way to put it. So we're not trying to eliminate uncertainty, but rather we're learning how to work with it.
Exactly.
And that, I think, is a very powerful concept because it means that even though we can't know the future for sure, we can still make good decisions and we can deal with all this unknown.
Absolutely. It's about being ready for whatever comes next.
Yeah.
Having the flexibility to change when we need to, having a mindset that embraces learning and evolution.
If you could pick one key takeaway for our listeners from everything we've talked about today, what would it be?
I think it would be that the future isn't something that's just, already written.
Mm-hmm.
It's something that we're creating through all our choices and actions.
Mm-hmm.
And in a world that's becoming more and more complex, more interconnected,
Right.
the ability to adapt and evolve,
Yeah.
that's more important now than ever before.
It's not about knowing all the answers. It's about knowing the right questions to ask and having the right tools to use.
Exactly. It's a journey of continuous learning.
So to our listeners out there, think about the parts of your own life where you might be, well, clinging to models that are too static or maybe even clinging to outdated assumptions.
Hmm.
How could you use the ideas we've been talking about, adaptation, flexibility, continuous improvement, to help you with all the complexity that we're all dealing with?
Yeah. How can you apply this in your own world? Great question.
And on that note, we've come to the end of our deep dive for today. Thanks for joining us. We hope you've enjoyed this exploration, and we hope you've learned something new.
It's been great. Thanks for having me.
And remember, keep exploring, keep learning, and keep diving deep. We'll see you next time.